Awesome. Okay, guys, we enter a whole new set of trigonometry. Up to now, we've been doing some fun stuff. Now we're going to even do funner stuff. No, we covered those. This is the fusion of algebra and trigonometry together. And its specific name is just called analytic trigonometry. Analytic trigonometry, fun stuff. All it just means is we're going to solve equations. So chapter 6 is all about solving equations. Oh, chapter 5. We made all these properties, didn't we? Man, we had the basic properties, right? Basic definitions, ratio property, reciprocal property, Pythagorean theorem property, right? That was before chapter 5. Whew. In chapter 5, anybody name some properties we did in chapter 5?
Sum product of sum, half formula, double
formula. There's a Pythagorean theorem
Sum
once.
formula.
Say again?
There's a Pythagorean theorem once. Is that what you're talking about?
Oh, no, what Abe was saying is sum to product, product to sum. Abe is going backwards in his head here. So that's chapter 5.5. 4 was half angles, double, and then we had just a plain sum and difference formulas. We good? We have a whole slew of stuff. Everybody okay there? Dylan, keeping all that in your head? Okay. We might use those properties, but we're going to start off a little easy first. We good? So keep those properties back of your head for chapter 5. If something seems familiar, like, you know what? I think that's going to fit a property. Okay.
You're still doing that math.
So with that said, let's go with it. We're going to just jump right in. I'm going to jump to this one right here. Let's review properties here real quick here. Just a reminder, man, look at that. Much as we can, we have, oh, and some more here. Hold on. Not meant to write this down, just for you guys to sort of see it. We good?
Oh, no.
Oh, man, there's some other stuff. Do you guys remember the co-function theorems? Remember those guys? Like sine, if you want to convert sine, if it's pi over 2 minus theta, you can convert it to sine for just theta. That's cool. Oh, the negative angles, remember that? Sine of a negative theta is negative sine theta because it's an odd function. You guys remember those? Crazy stuff. Cosine is even function, so we can just drop the negative there. What's some other ones? Quotient identities. Here's the Pythagorean theorem identities. Here's the addition subtraction identities. Double angle, half angles. That's great. Product to sum, sum to product. We're good. I think that covers all of them. Is that right? All the different stuff.
So many.
Whew. So maybe just the only ones that we didn't sort of see was this one right here, the negative angles. Don't forget those. We're good. And these guys may not come in as much, but right here, that one may come in.
Problem on the test.
I hated those. That was the even and odd thing.
Even and odd
I
functions
always got
here.
the even and odd mixed up, and then is it even or odd, and then it was horrible.
I'm so sorry.
Yes. Sine theta equals cosine of pi over 2 minus theta was on the test.
Wait, what?
And I had no idea how to prove that. And I was like, I can do it on a
Wait, that
graph.
one wasn't an identity. You didn't have to do it.
Yeah, it was just you had to plug in the values from that.
And it was wrong. You had to provide a counter. You just plug it in.
No, you graph it.
And
If
it
it's
was-
not an identity, you prove, you give a counterexample. If it is an identity,
And
you
it
prove
wasn't
the
an
identity.
so just give a counter.
Yes, it was. It was that.
Which one?
Sine theta equals cosine of pi over 2 minus theta. It's in the co-function identities.
This one right here.
It was the only honors. it was
That
the
nice one right
first
there?
Canon calculator problem.
Wait, that way was an identity?
Yeah.
Did I put it in wrong?
Was
I
the
don't
second
know.
one, the second one, was it?
I don't know.
as well?
The second one was an identity, yeah.
I don't know now. I haven't graded yet.
I thought,
I know, I had no clue what to do. I was like, I can't do anything to these. And I was like, I'm clearly missing something, which would be bad, because I could have just written sine theta equals sine theta and been done with it. But I literally wrote, I can do this on a graph, because pi over 2 is the phase shift. I was like, I can do that on a graph. I know this is the same thing.
So
I was
then,
like,
so how did you graph it? Because when I put it in the calculator like 4 different ways and I didn't get the same graph.
It's same. I tried graphing each one like 2 or 3 different.
Like I did
Uh-huh.
parentheses, pi over 2 and parentheses.
I did that.
See, I think your calculator does it differently though, because I did that exact same thing and it didn't do it.
Calculator's just better.
All right, so think back to algebra, stuff we did on the board. Think back to algebra, and we're gonna go like this. Very similar to what we just did on the board, except slightly changed. What? I thought we saw 2x minus 1 on the board, right? 2x minus 1? Oh, no, we had a 2x plus 1 on the board, right? This one's
So
2x
cosine
minus
theta
1.
equals -1. Oh,
You know what? I'm gonna do it like this real quickly here, just so I can
so
go like that.
cosine theta is now the variable, which means
Oh,
cosine theta
yes.
equals 1/2, which actually gives you.
That's at 60 degrees cosine theta.
Mhm.
Yeah.
So let's do a few things here first. So if you want to do it, jot down example 4 already. We skipped 1, 2, 3. We did it on the board. Those are the algebra stuff.
Oh, that was example.
Yep.
Wait, are we gonna have homework like that? Like the beginning problem is just gonna be like back to algebra?
I'll give Abe one like that. Just
Yes.
let's see if I can. Hold on.
Wrong, so I'm gonna forget the negative like I did up there.
Okay, let's see. We're gonna solve this, except for the one little thing. Do you guys remember? You know, when you graph cosine, cosine goes like this. Is that right? So notice if we're solving for 0, let's just say, right? How many times is it gonna hit a 0? An infinite amount of times. Oh man, so these guys are not too fun because we're gonna somehow figure out how many infinite times it hits it.
Wait, we're not solving this. It's 2 cosine theta minus 1 equals 0.
So cosine theta equals 1/2. From that, you know.
Sorry, Abe, I can't give you an algebra problem. It's only trig. Sorry.
Oh, I thought I had a chance to.
Okay, so first things first, we understand we have infinite answers. Is that right? There's gonna be a whole bunch of answers here. So there's a part A, says find all degree solutions forever. And then it says just find from 0 to 360.
Wait, find all of them. That's dumb.
So let's go with it here. I'm gonna turn to here and want to make sure this is all set. So let's solve like we did normal algebra. This will just be what? Adding 1 to both sides. And we're just thinking of cosine theta as an x. Divide by 2. Very good there. So now we want to do, we want to find theta. And theta is in terms of degrees, and we have part A and part B. We got to find all the thetas in the world that make cosine theta equal to 1/2. That's crazy.
So it's just 60 degrees and then it would be
Oh, okay.
4.
All you have to say is every 60 degrees infinitely.
Uh-huh.
That's your answer.
Awesome. So it's almost like easy. It's almost easy to do part B first and then part A, right? Because you have to look at a unit circle anyways, right? So let's kind of finish up part
Oh,
B,
wait, that's.
and then we'll finish up part A down here. So looking at unit circle, the question is what degree value gives you cosine of 1/2?
1 and 4, 60. So it'd be 60 and
60 degrees, it's like right here. That gives it to you because that has an x value of 1/2. Everybody good there? This is √3/2. And then down here, so that is 60 degrees. I got one answer is theta is equal to 60 degrees. Another answer is down here. Coming all the way across here, that gives you another positive 1/2. This is a negative √3/2 this time. And again, I'm drawing it out. You guys are just looking at a unit circle at this point, right? It is 300. Cool. Okay, I've got to
So
put
it's
degrees.
not every 300, it's not every 60 degrees, it's 60
Oh.
degrees and then not for 2 and then 300 degrees.
Yeah, that's not fun.
How?
Get like a loop, like condition.
There you go. There's a conditional loop here. Love it.
So it's
So hold on real quick here. Yeah, instead of like jumping every 60, right? If it hits a 60 degrees, right? Can't we just loop around one revolution that will hit the other 60 degrees? And loop around again another 60 degrees? So if this makes sense, look at this. How about if it's like this? To get the 60, we're already here, is that right? If I were to add another 360, would that give me to the same exact area? Yeah, it would, huh? That's so cool. Except I have to keep on doing it and doing it and doing it forever. Is that right? So here's what I'm gonna do. We'll deal with that in just a second here. So I'm going to do this right here. I'm going to put like this little k value right here. I'm going to define k. I'm going to say k is an integer. And let's see if this makes sense, guys. K is an integer. So if k is equal to 0, what do we have?
60 degrees.
So we got 60 degrees. Everybody good there? Oh, I did B. B is done. B is finished right over here. We did that. That's all done. Because part B is easier to do than part A.
Why didn't it give B first?
I don't know. Other math textbooks switch it around. Dylan, are we okay there? Does that make sense?
What's the difference between A and B?
Sure, yeah. A says I need all degree solutions forever. B says just between 0 and 360 degrees.
So A goes beyond 360.
You need to find all of them. So here's what we do. We say, look, we found one of them. We found one of them was 60 degrees. If I keep on doing it one revolution, I get up to that little 60-degree marker again, right? I do another one forever and ever. Hold on real quick here. So that means if I just do multiples of 360, like say 360 times 0 is just 60 degrees, right? If k is equal to 1, that's going to be 60 degrees plus 1 revolution. Is that right? Everybody okay there? Does that make sense? Tristan, does that make sense?
Yeah.
I just can't see you. That's why I'm asking. Okay. If it was 2, if k was equal to 2, that means it would be 2 revolutions, right? It was 60 degrees, and then you go just 2 more. Oh, the fun part. You guys ready? If I say k is an integer, that allows me to go backwards as well. So if I have a -1 in my hands, I still get where I need to be. You know, let me do a different slide for this because that's feels like almost like it doesn't make sense here. Hold on.
If it's -360 degrees,
So
gives you -60 degrees in this.
It'll be negative.
Yeah, but it's still.
Yeah, same thing.
now let's see this. So this is 60 degrees. If k is equal to 0, we are right here. Is that right? And we got ourselves 60 degrees. So then if I say, okay, how about if k is equal to 1? That's 390 degrees, which really is, we're in the same spot again. Is that right? We just did a 360-degree revolution. And then that allows us to go 60 more, and I'm same spot again. Okay, does that make sense? Okay. Because you guys were looking at me funny earlier, that's why. So then if I have, let's do another one here. Let's see if,
Wait, 60 plus 360 plus 390.
It's not 390. Yes,
oh, chief, sorry.
Okay,
What is it?
No. It was
That's why you guys looking at me funny.
420.
420, right?
Okay, yeah.
Okay. That's just 420, which is exactly the same spot. And if I say 2, oh, guys have to help me out here now. What's the 360 times 780 plus?
It's just 780. It would be 720 plus 60.
Perfect. Okay, so 360, 720, 780.
This show.
Who we are.
They're gonna make us. No.
It's not just follow a specific mathematical pattern, and that's not.
Conduit.
Okay. If this does this make sense as far as like twisting? And then if we if we do this here, we're going to take an integer of -1 value. Does that still get us where we want to go? So what is 60 minus 360? Yeah, 300, and it lands us right in the same exact spot again. Still gives us a x value of 1/2. Okay, we good there? So by declaring x to be k to be any integer in the whole entire world, we've allowed all the different possibilities for the 60. We're good? Okay, did this slide help a little bit in kind of the understanding of it? Cool. Okay, we have another answer though. I think we had it at 300 as well, right? So we're gonna write that as well, 300. Let's go back. And I'm gonna say the other answer is 300 degrees plus 360K. And do you need to define it again? No, once you define it once, you're okay defining it the other time. Sometimes people wait to the end, they'll define the first one, comma, they'll define the second one, comma, and then they'll put X in it. or k is an integer. Okay, you guys talk to me. Does that make sense there?
Wait, so yeah, you have to get both the 60 plus 360K and 300 plus 360K?
Yes, because we have two answers that are on the unit circle.
So where does it, so 360, where does that come from?
The 360 just
Scroll all
means,
the way around for the
yeah,
next
it's one revolution.
Okay.
Another way to think about it is you could also say like this right here. You could also say like 60 plus 360K is we get to our 60 already right here as we do that right there, right? And the 360K just does this right here. It wraps this way around, right? It does one revolution. You can do another revolution, and you can go different ways. You can go this way or that way. Okay. Sweet. Okay. Let's do another one here. A little bit more complicated, not by much. Let's go with it. Now we've got to deal with cotangent.
All right, and now we have to do the root thing.
Oh,
Can we keep that in the denominator? Or do we have to rationalize?
I think I want to keep it.
It's really easy.
Yeah.
I don't think I want to rationalize it because it allows me to have the X and the Y right away.
There we go.
If I rationalize it, then I'm lose that. All right, you guys tell me what to do.
Do you have to put cotangent into cosine?
No, you can keep it. There's kind of different ways to do it. Sure.
Recently just changed it to cosine. So plus one.
Plus one. Okay, let's do that here.
So if we just, I mean, do the each side is just cotangent. Or is it about it? What happens if you just do like so squaring it to 3?
Instead of squaring it.
Oh wait, no, I'm thinking about the wrong thing.
Yeah,
No,
it's interesting. You guys remember whenever we have like a 1 or a root 3, don't we always have a denominator of 2? That's the tricky part here. On the unit circle,
Well, that's,
whenever we deal with a 45-degree angle, with a 30-degree angle, or a 60-degree
Well,
angle.
isn't that technically 1/2
Thank
over
you.
root 3 over 2? but it just
Absolutely.
can't off?
So how about a 1/2 here? Okay, Abe, are we good with that right there?
So what is the one? So yeah.
We're going to put in a denominator of 2 because we know that whenever we're at a 30-degree angle, a 45 or a 60, we always have, all these values always have a 2 underneath it. So if we're trying to find the X and Y coordinate, you're looking for that right there. And so we just place it in a 2. And so this, oh, guys, tell me here, X or Y for the top for cotangent? X is good.
Wait, but how can you just put?
This is Y.
Oh, 'cause that's
Because
the
if you're
same,
gonna-
yeah, if you're getting rid of it.
If you split it by 1/2 over root 3 over 2, you get 1 over root 3.
Yeah.
Okay, that's cool too. Awesome. Okay, so I'm looking for this guy. I'm looking for when is, so we made this into a 1/2 and we made this into a root 3 over 2. We stuck in a 2 in both of them. Technically, what we did is we just divided both top and bottom by 2.
Because it's the same thing as if you have the 2 on both sides, you can get rid of it. And then we're doing this because we want the root 3 over 2 in 1/2.
Yep, we wanted to have a denominator of 2 because our unit circle has denominators of 2. The only time we don't need to do it is if we get a 1 or if we get a 0 or we get undefined, right?
Remember to do this specific process. Is there a way that you remember to do something like this? Because it seems kind of random looking at it.
Dylan was saying it's,
Yeah, I
Purpose
wouldn't-
wise, it's to
But I never
get
would
you
have
the
figured out.
full coordinate,
I,
so you
I,
can know what angle it is.
I know purpose-wise what it does, just like, in
yeah,
isolated
let me give you, let me give the long way.
circumstances.
The long way would be cotangent. Let's do the long way here.
I know what the long way is.
Oh, okay. Sorry.
That's not my question.
Uh-huh.
It's just that in a situation like this, how would you recognize this is what you need to do? And know you can find the X and the Y.
Uh-huh.
Typically,
Yeah.
what I do is just do cotangent plus 1 over the square root of 3 and then use that. Do some other method to find where it is on the circle, but this is much easier, so.
Yeah, I guess the only thing that you think about, like, how do you do it, is it only works with tangent and cotangent. That's the only time it works. And the reason for it is because when you define y over x, the r is gone, right? So technically it would be
Never mind.
getting a little lost in translation.
Oh, no, I understand what you're saying, but it's not what I'm asking.
Okay. Sorry, Dylan. It is not happening. Can you ask again one more time? See if that's.
It's fine. I feel like I'm just in a related concept.
Yeah, okay. Okay. Sorry, just didn't grasp it there. So real quick, can we find x being a 1/2 and y being a √3/2? Go.
Actually, that's 30 degrees. No, 60 degrees. Yeah.
That's 60 degrees again, man. That's no fun. I got that one. Except we're missing one more answer. Isn't that
Oh.
funny?
Oh, wait.
Now, Dylan, we have to remember this too here. Let's see. We have a ratio of x and y.
But if they're both positive, that's both negative, so then.
Oh, yes, that's
60
true.
degrees Quadrant 3. So 60 degrees is 180 plus 60, 240.
270.
270 or 240?
300 is a 60,
Hold on.
so you subtract.
Wait.
It's 240, because 180 is straight, and then you would have to add 60 degrees. So it'd be
Okay.
240.
Make
I'm
sure.
just thinking of numbers that are.
Gotcha.
Just picking one.
It's 270.
Okay, so we got 60 degrees and we have 240. Everybody agree with 240 now? We have that one as well. That's 240.
Why are these different 60-degree angles in this?
Because you have to have a positive and a positive. So the only way to do that is a negative and a negative, whereas the last one, it was a negative 1/2, so it only.
Okay.
Right, if you want to write this one in, that these two are the same, that's the issue here. A positive over a positive is the same thing as a negative over a negative. For tangent and cotangent, we have to consider that right there.
Wait, in the last one, I think I completely missed that. What is the negative?
Let's go, let's find out. Let's go.
Okay, the last one had no negative, which means it couldn't have been
Oh, okay, it's because
in the other quadrants.
Okay.
Yeah.
That makes sense.
Oh, all right. Still jamming. Okay, got that one, that one, that one. So I have this situation happening. I got a 60 and a 240. Can you guys write the, oh, you guys give me the answer here. So B, for B, the answer is, we'll do B as well for 60 degrees, 240 degrees. Okay, let's do A now. A would be
60 plus 360K or 240 plus.
Thank you. I'll write it the way the book writes it here. This one plus this one. K and then K. In fact, it even says this, where K is an integer. Yeah. Good there. Oh, look at this, guys, real quick here. Super cool stuff. Notice that this guy is exactly half a circle out, isn't it? Abe says you have 60 plus 180, is that right?
Wait. You can just do 60 plus 180K and all.
Sweet, okay. Tell me if you guys agree with Isabel here, because it only works if they're half a circle apart. So we could say this, we could say 60 degrees plus 180K. Okay, I'll write it the correct way here. So it says where, so I'll say where K is. Okay. Boom. You guys are cool like that. Okay. Now let's get into the fun ones. A few people still writing. Okay, just real quick, just making sure people that have not been talking as much here. So Max, Annette, Dylan, Tristan, you guys, does that make sense to you guys? Everything okay?
I do.
Uh-huh.
So for case of integer, like the last, in example 4, we just made K 0. Would it be 0 in this question also?
It can be any.
Yeah, it could be
number.
anything. I just gave you like references of like, hey, if K is 0, we just found out the answers for B.
Okay,
Right.
but like on a test or something, we would just keep it as K.
Yeah. I was just to explain a little further what that
K could
means.
be negative 200,000 or 2. So-
Yeah.
That's what I
And
figured.
be a very, very, like, let alone in really long math problem. Write all those numbers
Mhm.
wrong.
True, true. Okay, let's go with this one here. So first things first, we notice we are in, we are in radian measurements first. That's the first thing we notice here. Second of all, we notice that we have a sine t on both sides.
Subtract 3 sine t.
Okay. You sure? Maybe subtract 5 sine t to get the sine t by itself on one side, like we normally do with
I
x.
think you just subtract.
Yeah, let's have a vote here. How many say subtract? I'll give you two options here. Do this way, or just setting it equal to 0. Or do this way where we get the sign by itself on the other side.
Subtract 5.
Yeah, I
You
instinctively
can
want
just
to
swap
set
it
equal to
in.
0, but it doesn't make any sense because you're gonna put it all over on the other side.
Oh, gee.
We used to divide by -2 instead of 2, so it's easier. Subtract 5t and get -2t. And then you divide by -2.
Yeah, so let me write this out a little cleaner here. So we're just trying to get sine t by itself somewhere. And easiest way to do that, that one. And that one. I got a √3 is equal to a -2 sine t. Divide through by -2. And I'm just going to put the sine t on this side here because I like it better on this side. So I have a -√3 over 2, all yours, guys. Unit circle, tell me where it's at. The unit circle that's in your brain.
Oh, that could be a lot. That's at,
No, it's quadrants 2 and 3.
And that's on the,
And
that's on
Maybe
the
one, too.
30s, right?
but it's only for certain periods. Because for quadrant 2 would be at 240.
Because let's see, the y value has to stretch further down, right? Because if it's a 1/2, then that would be your 30, right? Because you're barely moving away from the x-axis.
The sine is the second one. Yeah, but then it's also at 150. We got 150, 240,
Nope.
and -3.
That's sine.
Oh, it's only sine. I was just going to. I'm so smart.
No, no problem. Would you guys say 240?
Yeah.
Everybody okay with 240? Because you have to move further away from the x-axis. That would be a 60-degree angle here, plus the 180. So that makes 240. I got this one. And then also I'm going to go with this one right here then, right? Everybody okay with 330 or which, or no?
No, it's just, yeah, it's just.
300. Okay, so I got T for part B. I have T equals 240 degrees and 300 degrees, right? 60 away from. That's for B. Oh, sorry, guys. Sorry. See? Bummer. We're not in degrees. Huh?
Would this be the radian equivalent of that?
What is already equivalent to these guys?
I,
4 pi over 3 and 11.6. Oh, wait, no.
Should not be.
4 pi over 3 and 5 pi over 3.
Yep. So we are going to do a little more with radian measurements here, just to get you guys used to it here.
reading like makes sense. Maybe it's just.
And then there's a movement among mathematicians to make either the whole thing just be 100, right? We move into quarters, things mean 25 and 25, or there's a movement to make the right angle be 100 degrees. So then everything is 400. So redefining the,
But imagine dividing
the
that into
degree.
thirds though. So we have like 33 and 30.
No one likes thirds anyway.
That's awful.
Quarters and halves are much cooler.
Also, you never hear anyone go, yeah, he's 5 pi over 3 radians west.
True.
We started doing that. I was never going to not. I should have never going to anything.
Okay, part B, let's see, they're not connected to each other. They're not separated by half a circle here. So I got t is equal to 4 pi over 3 plus, I don't know. Say again?
5 pi over 3. Oh, wait, no. Those are 5.
2 pi.
2 pi, that's right, 2 pi k. Next one would be 5 pi over 3 plus 2 pi k, where k is an integer. Okay, I think we got used to the good stuff here. We got used to just solving it out. So now let's put a little bit more complicated algebra to this here. I'm just kind of reading. A couple of people still writing things down. Go for it. If I'm going too fast, please tell me. When is not for me to speed write. For you guys to see it, understand it, and move on. This one, oh yeah. So more complicated, not by much here. So solve all degree solutions. We're going to go from 0 to 360. That's great. Oh, use a calculator and round to the nearest 10th of a degree this time. So it's not those ones that we have off the unit circle. Now we're moving off the ones that we have.
So you have to subtract 3 and then divide by 4. That's what we then do.
Negative 3/4, everybody good there? You guys have to write it out first though, so that's why. A little bit of work here, guys. Ready?
But this is radian.
We have to put it in degree mode. So make sure you are in degree mode. Next thing is this right
Oh, it's
here.
negative 3 over negative 3 over 2.
I'm going to do this here. I'm going to figure out the, oh, look at this, the theta hat.
Wait.
I'm going to figure out the reference angle in quadrant 1, and then I can just shift it over to all the other stuff. So reference angle is going to be sine inverse of a positive 3/4. And that will give me just the reference angle right here. Then I can move it over however I want anywhere else. So you guys tell me.
I just did it.
Go ahead.
The negative 3/4? Not the little change. Yeah, it's the same answer. It's negative 1.
Yep. Isabel, tell me how come it's the same answer, just -1 negative and 1 is not?
In this case, because it's in quadrant 1. So
And
it's gonna be negative. Well, the original is negative. It's like, it's in quadrant 1 if you're going like around negative.
yeah.
So if it's
True.
not negative, it'll be in quadrant 1.
Yeah, and we're just moving away from, we're just going south of it, right? And so if your distance is that much south this way, you're just gonna have this negative angle just moving south, right? If you're, or down. If this is your distance here, you're just gonna have the positive angle moving north. Or, you guys remember this little guy? Oh, even and odd functions, what happens here?
Oh, it
Negative
goes to the front, yeah.
sign there.
Goes to the front, yeah. So if I put a positive value in, it's just gonna be a negation of the negative value, right? The even and odd function distinction here. So what we do is we put a, again, if you can just negate it afterwards here. What did you guys get for the angle measurement though?
48.59. So I would just run that to 6.
48.6 degrees is what I got. Okay. So we're looking at negative values here. So I'm looking for these two right here. I'm looking for this one And again, it has to go from 0 to 360, right? I can't have negative values here. And then I'm also looking for this one, I believe. So I'm looking for that one.
Yeah.
That one to make that true. So go ahead, tell me.
I would just.
Let me see if I can kind of put a few more things in here. So this is going to be a reference angle of 48.6 degrees in quadrant 4. So we're
Okay.
48.6 away from 360.
The larger angle is 311.4.
And then this angle here would be 48.6 degrees past 180. Okay, you guys talk to me. Everybody okay with 315.4 and 228.6 and where we got them from?
I mean, I should type in 180 instead of 48.6. Like my hands instinctively did that.
We just find the reference angle of 48.6 all around.
No, not all around, but
Well,
the quadrants that we need the
you
sign to
don't have
be
to
the
worry
correct
about
sign.
negative 48.6 because technically, yes, you have an angle 48.6 degree angle. But what you have to figure out is where your y value
Is negative.
is.
Originally it was negative because it's the negative 3/4. So you know you're going to be working in quadrants 3 and 4. So then you have a reference angle. Both those quadrants are 48.6. So then we just do whatever needs to be done to get that angle in that quadrant. And so for quadrant 3, it means you have 180 already, and you add 48.6 more to get you into quadrant 3. For quadrant 4 is you're 48.6 shy of 360.
Okay, reference angle is only to the x-axis.
Yes, correct. Reference angles are only to the x-axis. Okay, part B is done. There it is, part B. Let's do part A real quick here. So they're not half a piece apart here. So it'd be 300.4 degrees plus 360K, 228.6 degrees plus 360 degrees times K, where K is, okay, almost done. So 18, 19, and 5 more problems here, I think, but let's jam. Doo-doo-doo. Let's see, we should do that right now. Okay. Yep, talk to me if you guys need to slow down before you guys can have time to write down the problem. Ooh.
That's not possible because that's bigger than one.
Oh yes, that's what I was looking for.
And so this is an error, and I was like, what did I do? It's like, oh, it's just not.
Okay, another one. Divided by -3. So let's see, 4/3 is greater than 1. Therefore, no solution, right? Impossible to have a sine inverse value. Take it as greater than 1. Cool, okay, that was the easy one. I like that one. Okay, we're good there. Subtracted. No problem. Okay, got a couple of people writing things down, so go for it. All right. Annette, what does loaded dipper mean?
What's that?
On your
Oh,
shirt.
this is from Diary of a Wimpy Kid. It's like the fake band they have.
Oh my gosh, loaded that.
Yeah.
Roger, that
Got it, okay.
man is so good.
Diaries of a Wimpy Kid, right?
Yeah,
That one,
yeah.
okay.
Roger was the only like normal one out of all of them.
But yeah,
Yeah.
it's a classic teenager.
Greg was a psychopath.
It's true. And so was Manny.
He has babies.
Yeah.
Raise your hand if you watched it or read the book.
No, I
I
didn't know.
only watched it.
Watched it, yeah.
I should have read the book first. You always read the book first.
Okay. Max, no, I have not.
If I watched enough movies, I would have like some sticker somewhere that said the book was better, but I don't know watching enough movies. So it doesn't make any sense at all.
Greg was like self-entitled and no regard for anyone around him.
Oh, wow, okay. So is it just what, a bunch of teenagers and then just how they work out personality wise?
Not a little kid, like just on the high school.
Yeah, he's a middle schooler.
Yeah.
Yeah, middle school. I thought it was like 7th or 8th grade or something.
Yeah.
right?
Greg was horrible around. Like,
Yeah, he gets obsessed with this girl and just like gives up everything, like messes up with his family and his best friend and everything, just to like talk to her and get money. It's like.
Oh, wow. Gotcha, okay. And then you have the personalities in between that, right, sort of thing?
Yeah, like
Gotcha.
a classic lazy teen older brother.
Mm-hmm.
And drives a dirty van, sleeps in like 12.
Okay, let's see what we got here. I think we have some identities coming our way now.
You have what?
Oh, no, maybe not some identities. Let's see. Got to figure out how to solve this guy here.
You have
No,
cosine
two
and
sine
minus.
x, cosine x is the thing.
Say again?
2 sine x, cosine of x is some
That's the sum
identity.
formula for sine.
Double angle formula?
Like,
for
yeah,
sine?
it's sine of two.
Then the question is, does that help us to solve the
No, because
problem?
right now we have a cosine x and a negative cosine x. We cross those out. Oh, they're gonna apply.
what is it? 2 sine x cosine x is 2 sine 2x.
But does that actually help us?
Yeah, so let's see. Don't write down what I'm going to write down. If I have it like this, did that help us to solve this?
I was just trying to
Maybe you should set it with
manifest it into a-
Oh, you know what? Hold on, guys. Look at this. Isn't this guy set equal to 0? If this guy set equal to
Oh,
0,
hang on, subtract, add 2x, divide by cosine.
ooh, no, because then we're going to lose a variable of x. We can't divide
Wait, if
by
it says
x.
0, then we know that cosine x equals
Almost there.
2 sine x cosine x, right? So cosine x equals sine of 2x.
So close.
Cosine x equals sine of 2x.
Is it something to do with the cosine x now equals the double angle of x?
Sorry, guys,
Yeah,
leading you in the
lost
wrong
us.
direction. Yep, lost us. Sorry. I'm gonna go like this and see if you guys agree or disagree. Factoring. Factoring seems to help here. Set equal to 0. I should have given you a hint of set equal to 0. Set equal to 0. Oh, now we can split them. So we're gonna try to figure out when this happens. And then we're also gonna figure out when this happens.
Oh, yeah.
Yeah,
that was a
the
great
thing. We
thing.
have like the x equals x minus 4 and x plus 2 equals 0.
Mhm.
Our teacher told me to remember how.
Let's see, subtract 1 from both sides, divide by 2. I think I'm looking at something looks like this. Is that right?
Cosine x equals 0.
Oh yeah, when does cosine x equal 0? When does cosine x equal 0? Yep, at, no, pi, no.
Oh, wait, no. Pi over 3 pi over 2, right?
Yes, I think so, yeah. So pi, whoa, that was weird. It's not letting me, okay. Pi over 2, everybody good? And 3 pi over 2, there it is. Okay, and then cosine being a positive 1/2. What is that gonna give us? What we need?
Positive 1/2. 60. So it's positive at 30. Yeah.
And then you guys tell me in oh man, in radian measurements.
So that's
No,
pi
it's
over
sine.
6.
Oh,
Go ahead,
pi-
Isabel.
Yeah.
Yeah, pi over 6.
Over 6.
And then it's also at 150,
Mm-hmm.
which is 5.
Okay. I think I got my A value answers. There it is. 1, 2. I got 4 answers for this one. And then how do we write the B value? Oh, sorry. Yeah, sorry. I got my B value answers. There's 4. And then think about how we should write the A value answers.
Cosine is just 5 2 plus
180.
180.
Yeah,
Or
180 and plus pi.
plus pi. Good. So let's go with it. Let me rewrite this on the next slide.
Plus pi k, k is an integer.
Mm-hmm.
That-
So for part B,
Oh, it's an integer.
yeah, for A, it's going to give me this plus pi k. So are we good there with that one? Because it's a half a circle variation. These guys are going to be a full circle variation. Okay, boom. Let me just check out something here. Yep. Okay, let me go back to this one here. And I think we have time for that. Okay. Okay, jamming. You guys, did we learn something today? We learned we can solve trig functions here. I think the craziest thing is we're solving equations with like letters inside stuff. You know, when you, like, if you were in elementary school and you saw that right here initially, like, what? I got a COS and then an X, and then I got a SIN. I got words here and I got letters here, and they mean something. So that's kind of cool.
Yeah, we're the objective.
Oh, yeah.
Oh yeah. She would go get it.
I saw it, but it was like kind of like going up and down, so I just wanted to let it fly.
I'll take that side.
All right, guys. Oh, this one, and I think there's something on the board that'll help you through it.
Oh, yeah, it's right there. See, I have to do the quadratic formula.
Got it. Are you serious right now?
Wait, no, but we already did the quadratic formula before. It said -1 plus -2 equals 2.
Oh, running.
Just nab the, sorry.
That was trial.
Yeah, I could probably kill the child with quotient identities.
No, it didn't.
You don't know what if it was a black widow, so.
That was, I have seen Black Widows.
Remember
never
that
knew
baby that died 10 years ago with that item?
Hey, the only recorded death of a Black Widow, they found her empty jar of sleeping pills. They found
And
that
it's not actually death before you.
right, exactly.
The spider bite even hurt. Like, wow.
I've been bitten by
It hurts
spiders.
after, like, not while you're being bitten.
No.
It's like a shock. It doesn't actually hurt. So they take it kind of-
No, I was one morning I woke up and she had some four bites an hour. That's 24 hours. That's fun.
I was on my bed and I have like those videos got my contact and I look up and the spider just dropped on my face.
Oh wow.
Yeah.
Oh
I
wow.
had a massive wound on both arms.
Wow.
And I go to school the next day and my classmates are like, what happened to you?
Can we
I
do
really
what
don't
we did
know.
over there?
Absolutely.
But then, how does that help us?
Wow. So it's not X anymore, right? This is cosine theta.
-1 plus or minus 2.
Sure, yeah. I'm gonna do that in just a second here. So this, I'm gonna write out what we did over here, but I'm gonna do it the fast way here. Just so we already did it anyways here. 4 times 2 -1 over 2 times 2. And again, the easy answer, the final answer to this one, so I don't have to do it all. This would be -1 plus or minus the square root of 3 over 2. Okay, now let's see what's gonna happen here. I think this will have to be,
You have to figure out when you put it in.
yeah, and
Oh,
with
wait,
the
that would just be
with the calculator though.
with the tablet, okay.
And you know what? No, we have to do that. Yeah, so we have 2 different possibilities here, is that right? I've got a -1 plus √3/2, and then I got a -1 minus √3/2. Okay, 7 minutes left here. Let's see if we can put this together. So I'm going to write the two problems here I have. So just kind of, you know how we just split off that one into two different pieces, like the cosine? The previous problem, you know how to split off two different groups that equal to 0, right? Well, we kind of do the same thing here. So we got a -1 plus √3/2. And I'm going to have a cosine of a -1 minus √3/2. And I guess this one I need to use a, let's go about 4 decimal places here. What is, or if you can put it exactly in your calculator here. So I'm going to do this here. Can you guys figure out -1 plus √3/2? What is that? Is that a positive or a negative?
It's gonna be a.
Negative value?
No, it's positive. Root 1 is already 1, and root 2 is bigger than 1. -1 plus that would be a positive.
Yeah, it's almost close to 2. Yeah, it's like 1 point something.
So it's a positive. And then that one's gonna be a negative.
That one's for sure a negative here. So since this is going to be a positive answer, we can use this as a reference angle directly. We good? So I'm going to go with reference angle cosine inverse of -1 plus √3/2. And what did, yeah, remember, because with the calculator, we just want to know what happens in quadrant 1, then we'll do the rest of it.
Even though it's cosine, so you're gonna have to find when your x is positive.
Let's make it representative, you just turn it into numbers.
You just make sure it's positive before you take the
If we're taking it-
inverse of it.
Oh,
If it's positive, it stays positive. If it's negative, we turn it into positive. So let's finish up with 4 minutes left here. Anybody give me the angle measurement here? What does the calculator say? I guess that's the question. To the nearest 10th. And if that's too much for you guys to do the calculator here, then do -1 plus √3/2, and then maybe like do 4 decimal places or something like that, because I'll give you at least a good reference there.
Oh, hang on. I remember again. I have 68.5.
Sounds about right. 68.5 what?
29.
29, so 5. So for part A, I think you guys can finish up part B here. So because that's positive and that's positive, I'm looking for an answers of 68.5. And since x still needs to be positive, I'm trying to figure out this one as well. What's this one going to be?
So that's
That's just gonna be 270 plus, 369.
we're gonna do 1.5.
291.5. Cool. Okay. So theta answers are 68.5, 291.5. Good. This one right here. Careful, this one. We're going to plug this into our calculator. -1 minus √3/2.
Not gonna work.
And let's see if I can do that on my calculator here. So there we go. With a few minutes left. Let's do this one together here. Those that have a calculator with you guys here, I'm going to just jump into it here. I need to negate it first, right? I need to have the positive before I take it out. And so if I do that, make sure I'm mode, make sure I am in degrees. There's that. That's cool. So I have a -1 minus √3. Is that what I have there? I'm going to divide that by 2. Is that what I have there so far? Notice I am keeping all those digits, right? I'm not, okay, so then I'm going to multiply by -1. Aha, make it positive. We're good. We're good there so far. And cosine inverse of my answer. And I put all that together. What? No fun. What happened?
Well, there wasn't.
-1 minus the square root of 3.
Yeah, that's going to be a negative for sure. -1 minus something.
Yeah, that's negative for sure. Divided by 2.
One.
What's
so-
what's the problem here?
Oh. it's more.
It's too big or too little, right? It's actually below -1 or above +1. So
Oh.
that does not work. We good?
Because on negative, it basically means 1 plus root 3 over 2.
That makes it to be between -1 and +1.
That doesn't.
And now when we are subtracting it, that gets you into a -2 range. Divide by 2 makes it -1.3. Doesn't work. We're good? Okay, the only ones we didn't do, you guys won't be able to do on the homework, or you could try. These ones right here that have an extra piece in the angle. We're good? Don't do those, but the rest of them you guys should be able to do. Cool. And we are done. Yes, send you guys a homework sheet. Sure, you guys, absolutely. That was super fun. I totally enjoyed teaching you guys, and you guys are really cool. You guys are a cool crowd.
Kind of makes sense. Algebra.
So like, yeah, I think we have a reference point of algebra, so it really helps a lot.